Gravitation, problems on universal law of gravitation. So we'll do a problem using the universal law of gravitation. Problem. If the distance between two masses is increased by a factor of 5, by what factor would the mass of one of them have to be altered to maintain the same gravitational force? Would this be an increase or decrease in the mass? So what they say is the force is the same. So we are maintaining the same force, and for which if the distance between the two masses is increased, then in order to maintain the same force, what is the other parameter that need to be increased or decreased? Which is the mass. So one of the masses need to be taken care. So whether it is an increase or a decrease. This is pretty simple to find out from the equation of the force. The gravitational force equation, which is our universal law of gravitation, gives us the product of masses by the square of the distance between the two masses. So let us say when the distance is r, then F is this. If the distance becomes 5r, because it is increased by a factor of 5. So if r becomes 5r, then what will happen to the force? Then force becomes, let's say that is F1. It becomes G m into m by 5r whole square. That means G m into m by, take away r square, then you will have 1 by 25. So this is nothing but the force. So F into 1 by 25. Now this is what the new force is going to be. So if force has to be the same in both cases, that is if F1 has to become F, then the product of masses should be multiplied by 25. That means one of the masses has to be increased 25 times. So to make F1 is equal to F, then M, capital M or small m need to increase by 25 times. So it gets cancelled and we will be left with the same force. Let's see next problem. How does the force of gravitation between two objects change when the distance between them is reduced to half? So when the distance between them is reduced to half, that is r is reduced to half, then what is the effect on the force of gravitation? We know gravitational force is given as G into mass of products, product of the masses by square of the distance between them. Now in one case, the force of gravitation, if the distance between them is r, force is this. If the distance between them is r by 2, because it is reduced to half, so r by 2, this becomes r by 2 whole square, which is nothing but G into m by r square, and in denominator 4 will come to top. So this is 4F. So what happens to the force? The force becomes 4 times. If the distance between the two objects is reduced to half, then the force becomes 4 times.